Well, thanks for joining me. My name is Mark Downey. I am an application engineer with GoEngineer. It was formerly Desai Solutions, if you were familiar with that. I presented once before, a couple months ago here. It was with Desai, and in August we got acquired by GoEngineer. And John and myself are both with GoEngineer now. John's our sales guy for Kansas and Missouri, and I'm the application engineer for the area. And so I'll come down to present today. We're going to do equation tips and tricks. Let's see here if this is working. So a little bit about myself. I am a Bachelor of Science in Mechanical Engineering from Rolla, University of Missouri Rolla, back in 1988. And so I've been around a little bit since then. Worked for McDonnell Douglas in St. Louis out of school. Then I went to work for Dayco Automotive Hoses and Belts in Ohio. Then from there I went to Levelor, which is a window covering company. Did metal horizontal blinds for a few years. And then from there I went to actually a SolidWorks reseller back in '97, shortly after SolidWorks came out. And I worked for a reseller for a couple of years. Then I worked for an extrusion and an injection molding company in North Carolina called American Extruded Plastic and Injection Molding. And then from there to Hunter Douglas, which is another window covering company. And spent 14 years with them doing designs for shutters, custom shutters. And then my wife and I got our 4 kids off on their own, and we decided to go escape to the farm that we inherited up in northwest Missouri. So this is a picture of my farm up in Missouri that my wife and I live on now. And so when I'm not doing SolidWorks, I'm out trying to, we're kind of restoring it. Actually, my grandpa was raised on this farm, and my dad was raised on this farm. And so we're in the process of trying to restore it. It's been neglected for a few years, so we got some work ahead of us on that. So that's what I do when I'm not having fun with SolidWorks. So this session is equations. I'm going to go over, this is kind of what I laid out for today. I'm going to talk a little bit about some basics, a little bit about global variables, equations versus geometry. When's it better to use geometry versus equations? I'll look at some of the functions that are with the equations, example of how to use an if-then statement, some feature suppression and unsuppression. You can use equations to turn things on and off, how to configure equations, and how to use equations and configurations. You can export equations if you got them created, and you can link them to a file. I'll show how to do that. And then I played around a little bit with equation-driven curves at the end, just to kind of show some of that if you haven't seen that before. I guess I'd like to start off with a little bit about, get an idea for if you're using equations now, how are you using them? If we just quickly go around the table, are you using equations in your work?
Yeah, I have a structure model that I use equations. So like if I have like a basic geometry sketch, that if I change any of the sketches, like the width or the height or the depth of it, that it'll update all the pieces in the structure.
Cool. How about using equations?
Math is a mystery to me. I want to figure it out.
Okay, cool. Are you using equations in anything yet?
For the liability, for the mini use for life.
Okay.
I'm good at deleting equations. If you've ever downloaded anything for McMaster car, they use equations to drive, use one model to drive a whole family of, say, fasteners. Or
Sure.
whatever. And then we download that, and then we try to simplify it to take it easy on the computer, so we delete everything that's unnecessary.
Gotcha. Okay. How about?
I've been both spectrums. I've been like top-down models, full equation-driven, and then I've kind of leaned back and do simple part equations. But,
Okay.
I'm fairly
Okay. Well, hopefully you can pick up something new today. How about yourself?
Here and there, not so much in SolidWorks.
Okay.
So.
All right. Equations?
Not really.
No? No? Larry? No? All right. Well, so we got a little bit of some basics, and then we got some more advanced, and so we'll kind of cover some spectrum here. Equation basics. When you look at the equation, this is a little bit about the equation editor. There, when you pull up and start an equation, this is the dialog box that you'll see. And there's 4 different buttons across the top that kind of help you understand the equations. The first one is the equation view, and this lists The global variables, any feature suppressions and equations, so this is what you see when you look at that. Then the next screen is the sketch equation view. It's this button here. And if you have equations, you can create equations, sketch-based equations, and they'll show up here. And this is where you manage them. And I'll show this in a minute in SolidWorks. Then there's the dimension view, a little bit different view. It shows the dimensions, the sketches, the equations that have dimensions associated with them. And then the last one is an ordered view. So equations in SolidWorks there's an order, it has to be in order. They have to be from top down. And you also can create circular references if you're not careful as well. So, let's go back now. Let me jump over to SolidWorks. And I will bring this up. So global variables, and I'll talk about the equation views in a minute, or when I work on this one. Global variables are intended to be used in equations. They're similar to linked values. If you've ever used linked values in your models, you can link two values in two different sketches, and it makes them, they change the same way. Global variable can be done the same way, but it's a little bit more flexible. And so let's take a look at that with this model here. I just threw this model together to kind of show some of this. So equations over here in the feature tree on the left. And if we right click on this and manage the equations, this is the different boxes. So again, you see the first tab, and this has got some if-then statements in it. And then here's the ordered tab. So if I want to create a global variable for this one, I'm going to start by double-clicking on the diameter down here. And if you click on the dimension, you see it's got the dimension name down here, D2 at Sketch 1, which we're all familiar with. If you want to create a global variable, you just have to start typing a name. So let's say if I want to make this OD, if I type OD for outer diameter, notice the little icon pop up there. It's got the little global variable. That's going to create a global variable. So when I click OK on this and go back to the equations, it created a global variable. And I can use that global variable now in the equations. So if I go over, like D2, it was D2 at Sketch 1 is the OD. So if I can go here and change this to OD, not ID, OD, there we go. Let's change this one here. So it can help shorten equations and make them a little bit easier to understand if you use global variables to do that. So that's a quick way on how to do that. Yeah.
You're using quote marks on both sides?
Yes. Yep. You have to use quotes on both sides of them. Mm-hmm. Any questions
So
about that?
you already taught me something. I know you can type it in there and it would just create the global
Yep.
variables.
Yep. And so if I go back to this and if I double click on this now, where'd it go? Well, what did I do? Let me do that again. I'm going to do OD. So go back to equations. Yep, so you can type it in. And this should be D2 at,
Would you need to put equals before OD? And that would create that equation?
I think you're right. I missed that part. Yep. And since I created a global variable, now it's in my list. Thank you. That's what I forgot. I've only been using it since 1997. Always on something. But yeah, so I had to type equals to it, and now it tagged it to it. So that makes sense. So that's global variables. Again, they're easier to manage than linked variables. And again, if you're linking variables, if you wanted to link, give an example here, if I wanted to link the height of this to this diameter, you can right click on the dimension and click link values, and then you give it a name, and you just say height, and click OK. And you see the little link icon next to it. So if I wanted to link this value to that one, I could right click on this, link values, and I could set this to be height, and now they're linked together. So if I change one, it's going to change the other. But it's not managed in the equation management tab. So it's easier to use global variables. It does show the link here, but it's not. You have to drive it by changing the dimension in the other. If you want to break that link, you just right click on the dimension to unlink the value, to go back and forth on that. Okay. So equations versus geometry. When's it, one or the other? You can use equations for both. These two parts look exactly the same, right? I've got one set up to be driven by equations and one set up to be driven by geometry. So you kind of have to look at your part and see what makes more sense. And so I'm going to open both of these up. And we'll tile the windows here. So this one on the left is driven by geometry. I've just got a hole pattern, the hole pattern down here. You can see the sketch geometry here. I'm going to edit the sketch. So I've got a center line that's constrained to the center of the part this way and a center line this way, and then that's coincident with the center of that center line and mirrored. So geometry drives the whole thing. So if I change the width of the flange, like that, everything stays centered. But you can do it with equations too. But if we look at the equation version over here, it's a little more complicated. I had to drive an equation here, drive an equation here. So there's a lot more equations. It's probably simpler to do it with geometry. And the equations over here, it's half of, basically set up, D1 extrude thin. Now here's an interesting one. RD1, it's a reference dimension. You can actually use a measurement value when you create an equation. So let me show how that works. I'm going to delete this one for a second. And I'm going to throw that dimension in there. Let's maximize this. Use the S key to bring up quick toolbar. And I want to put the dimension into here, from here to here. I want it to be equal to, and notice when I do that, it's not coming up with it. Let me just go ahead and just put the 1.25 in there. Well, so you can set it to be equal to a measurement. Let me recreate this for a second. If you can create a measurement in your equation. And if you haven't noticed, I'm running SolidWorks 2020, and it just crashed on me.
Service pack 0.
No, this is SPO 1.1. So, but thank you for trying.
I was trying. The sales guy always tries.
You can use a reference dimension to create an equation, and I wanted to show that. I just create a real quick extrude here. And let's put a hole in this. Need to save it, so let's do a cut. Right click through all. So if I want to use an equation for this that's a measured value. Notice it comes up with the measure down here at the bottom. So I want that to be based on half of the distance from, so I clicked on measure, notice it came up to equal, and I'm going to click on these two lines, it's going to give me a dimension. So now it says reference dimension. So it's based on the physical geometry instead of the sketch dimension. And I would say divided by 2. So I can create an equation based on that. So it's driven based on that actual measured value. So you can use that.
It's probably a little dangerous though, isn't it? So say you filled it in that corner, now that dimension gets orphaned, doesn't it?
Could be. Let's try that. Let's see. So if we go in here and fill it this. Yeah, it moved it back. Yep. So something to be careful. It's a tool,
Yeah.
but you have to be a little bit careful with it. This is a list of functions from the copied and pasted from the function editor. So when you go in to create functions, sine, cosine, tangent, secant, you've got square root, integer, if then in your if then statements. So that's when you go to create an equation, those are available to do that with. Like for example here, I just drew a circle and drew the distance between them, and then used the cosine to get the length. You wouldn't do that, but that's an example of how you would do that. You cosine of the hypotenuse, and it gives you the x value of it. So, but you can use equations. Those are the listed equations you can use. How to use if-then. So on this part here, I've got this set up to where as the length of this changes, the number of holes changes, and the distance doesn't go any greater than 2.5 inches. And so the way you do that is through this, and let me zoom in a little bit on this. So there's no roundup function in SolidWorks. So you kind of, in this case, I always wanted to add a hole if I got to 2.5 inches. So I needed to round up if I at some points. So what I did here is I've got an equation that says actual, and this is the length of the part minus 2 times the distance from the end of the part. I've got it set up to be 3/4 of an inch from the end. That's what the D1 is. So it takes the length of the part minus 2 times that distance, and it divides by 2.5, which is what I want the spacing to be, and then it adds 1. So that's how you determine the number of holes, okay? So length minus the ends divided by the spacing gives me how many holes. Add 1 to get it. So it's telling me 5.56. The rounded, and there's a round function in the equation, so I can round that actual number. I used the global number there. So I rounded that, and this is what the rounded value is. And then I used that rounded value to tell me what the hole distance was. Well, it says it's 2.28. I get the actual hole quantity. I'm saying if the hole distance is greater than 2.5, then use rounded plus 1. Otherwise, use rounded. So that's how I did the round up to get it to round up. So if we go back over here, I change this to 14 inches, which is a magic spot for this. And then look at the spacing here. 14 inches, that spacing is 2.5 inches. So if I increase that spacing to 14.1 and rebuild, it threw in a hole, so the spacing didn't exceed 2.5 inches. So that's a use for if then. Does that make sense?
We use this a lot. We actually incorporate a fractional rounding in there as well by taking it times a. For instance, we want to keep 16 units.
Mm-hmm.
Take it times 16 and then add it together and divide it. And
Yep.
Yeah, it works really well.
Yep. Any questions about that so far? Makes sense? Feature suppression and unsuppression is another tool for that. And if we look over here at the equations, under the features here, I've got the counter bore to be suppressed if the diameter is less than 6. And then down here, I've got the hole quantity to change. If the diameter is less than or equal to 9, use 4, otherwise use 6. So Instant 3D is kind of fun to use on this one. I can click on this part, and I can grab the handles here. So I'm going to grab the diameter. As I grab the diameter and bring it out, see the holes jump up to 6. So use the if-then statement to drive the hole quantity. If I bring it back into below 6, then it's going to suppress the holes. So that's using the if-then statement to suppress features. Make sense? Any questions about that? Maybe see a use for that in some designs? Okay. I'm going to use the same example for configurations. If I want to make, so this part's got 2 different configurations. I've got a default and a no hub version. And notice the whole quantity's changed. So if we look at the equations for this, down here under the circular pattern, since I've got 2 configurations in this, up here on the top right is the configuration options. Notice the equation here says if the diameter is less than or equal to 9, use 4, otherwise use 6. If I go over here to the no hub, notice the diameter, the equation changed 5 to 7. So you can actually set your equations to be based on your configuration. And when you click on an equation, you see the configuration option over here, so you can switch, what configuration that equation applies to. That's pretty cool. Exporting equations and linking. If anybody used exporting before in equations? So this is one that I drew up. This is a tank model, and what I did here was I used a global variable to say, okay, I want this tank to be sized for 500 gallons. And then I used an equation then to determine what the cubic inches is for that, to convert that. And then I wanted to know what the maximum diameter was. So basically, what's the diameter? If there's no straight section, it's a sphere, right? So this equation here calculates what that spherical diameter is. If it gets to that value, then I don't have any straight sections, so it's going to error out on me. So I did that just so I know what the maximum diameter was. Then I've got a global dimension that's driving the diameter, and then this A value is driving the distance between the 2 ends. So the length of the part is the diameter plus A. So if I go in here and change the diameter to, let's say, 48 and rebuild, the tank gets smaller to maintain that 500 gallon size. So, and this one's kind of, I set this up with, there's 2 solid bodies here. If I roll back in the tree to the revolve, this revolve here is the internal volume. And then, so if I do a section on this, see, it's solid, okay? What I want is the tank, though. So to get the tank, I did a shell and did a shell outwards. So if I edit this feature, I did an outward shell. So it shelled it to the outside and got rid of that internal geometry. So now I've got a hollow on the inside. And if I do a section on that, you can see there it's hollow on the inside now. But I want that internal volume so that I can add the 2 volumes together to get a total weight, for example. So what I did there was I did another revolve to get that internal volume, and I changed the material for, I can expand it over here. I've got the material for the tank to be plain carbon steel and the material for the internal to be water. So now if I do a mass properties on this, evaluate and do mass properties, the total mass is 5,027 pounds. I could clear the selection and click just the tank, and the tank itself weighs 855 pounds. Or if I don't know the weight of the water, using the density for water, it tells me that there's 4,000 pounds of water in there. So using multi-body solids and equations to drive all that, I can say I want a 500-gallon tank and have it size everything like I need it to. How are we doing on time here? Any questions about that? Does it make sense? Can you see use for that? Cool. Oh, wait a minute. I want to go back. I wanted to export those. So I'm bringing them back up again. So the way you export equations is under the Manage Equations, there's the Export button over here on the right. You click on Export, and you just basically tell it where you want to put the file. And I'm down here. And Tank Equations, Save. And when you do that, you get the option of, so you can link them, so you can have it linked to the file. And when it's linked to a file, it's a text file. So you can go into that text file and change the number, and it'll update the model. So you can have it linked. And this is a way where maybe you've got an external, somebody outside is doing the calculations, and they send you the calculations. If you create this file first and give it to them, and they change the numbers in it, you can bring that file, when you open that file back up again, it'll update your model. So that's kind of a cool way to use that. You can choose to link it or not. If we go ahead and I'll export this. Notice it puts a link column over here on the right. So if we go open that file, there's the text file. That's what it exported. And let's say I change the tank volume to 5,000 gallons and save it. Go back over to the model and rebuild.
When you close your equation dialog box, you hit cancel when you export it. I don't know if it kept the links.
Let's see here. Oh, thank you. So I can import that now. Let's go over to there. I can import that external file. Duplicate equations exist. Remove the duplicates. All right, so now let's go. This isn't working quite like I wanted it to. Manage equations. Let's just start this one over. How about? Here's my link. All right, so let's manage equations. I'm going to export those out to Tank Equations. We'll override it.
The only thing you can export?
What's that?
Is text the only thing you can export?
For equations,
Okay.
as far as I know.
So
Yep.
it's-
All right. We'll click export. All right, so now I should have that linked file. So now if we go open that file, let's change this to 5,000. Hit save. So now I got a 5,000 gallon tank. So you can use that external file to drive it. Okay? Anybody ever used equation-driven curves? This is wild. I've been playing around with this all week. I mean, it's like I've used it before, but it's like I never really had much of a use for it. I was looking for really fun equations. It's like I went and searched into Google for equations.
We built a winch that has a helical spiral wound pulley or ship, and yeah, I was trying to calculate cable length, and it took me a while, and I ended up finding some help on the forums of how to do an equation-driven helical spiral. So,
This one, I found this is called a granny knot. And if you look over in the feature tree, there's just two features, two sweeps. And I'll roll back before this one. This is just, I just did a mirror of the sweep. It's a 3D sketch. Edit the sketch. And to get to this, when I click on it, notice here on the left, there's the equations that drive that. And it's really, I mean, you go out there and find, this is a parametric. Now, in a 3D sketch, it's parametric. You can do it, and the way you get to this, if I start a new part, start a sketch, it's under spline, and there's equation-driven curve. That's how you get to it. And in a 2D sketch, which is what I went into, you can do explicit, where you do y equals mx plus b. You know, you type in an equation, and you put your x values, your starting and ending x values. Or you can do parametric, where you do x is a cosine of the t and y is a sine of t, and then you do your two t values. So that's how you go in and put the equations there. Now, if I start a 3D sketch and go up here to equation-driven curve, it automatically goes into a parametric. There's no, the other option isn't there. So you have to put in equations for each of the x, y, and z values, and then the t. So it's like y equals sine t, like in that other example. So if we go back over to here, you click on the value, then there's the equations over there on the side. Pretty cool. This is amazing. If you know what the equation is, you can graph it like this and draw it out. And I just did a sweep around that to get the values. So it's fun to play around with the equations. You have to be careful if you do self-intersecting. If it self-intersects, then it'll give you an error and it won't generate it. And I can do that with this one. I wanted to make this flatter, so I thought, well, the z value. Let's go over here. I want to make the z value 8. It may or may not work if you change that multiplier there. See, it generated self-intersecting, but I'm not sure it's going to last very long. My geometry self-intersecting, that one worked, but it's errored out on me before. But so that's pretty much what I had. Any questions about anything on that so far? That's, as I mentioned, I live on a farm. I got some trail cams set up. I can't believe these two bucks got at it right in front of my trail cam.
That's awesome.
So, and you can see another one over here in the background. I don't know if anybody's hunters or not, but these $3 up on my north of my property.
He's waiting for the winter back there.
no, he's going off chasing the dove.
That's right.
Well, they're busy.
I'll go out. I'll have dinner.
I've seen the same thing happen in a nightclub.
So we have a
Stack
winner.
beer, right?
Yeah, that's pretty good.
I've counted 7 deer in this trail cam at once up in this field. It's really pretty wild. So
It's 8 o'clock in the morning.
that one was 8 o'clock in the
Oh,
morning.
good time.
Yeah.